N. Okay, there is a difference between observational data and experimental data. Okay, experimental data is what you get when you're a scientist. You say, okay, I want to find out what happens if we use this chemical here and we give it to this person and we don't give it to this person and we measure and so on. Or we could do it in this class. We could do a statistics test at the beginning of the year and then we do another one at the end of the year and we see, have you improved? That's experimental data, and it's collected specifically for a purpose, and it's way, way better data than observational data. Observational data is stuff where you just happen to collect it as you go along and you haven't set up an experiment. And often observational data is much dirtier because you haven't stopped to think about what it is that you're actually trying to collect. So, but in business, observational data is often what you want to get. And especially in things like economics, which many of you will be doing, except for the little experiments that they run here, which are almost more like psychology experiments, economic data is not experimental data. New Zealand is not an experiment for the rest of the world, though sometimes it feels like it. When you do things in the economy, it just happens, and you take this data and you can't run it again. You can't say, okay, let's try now, we'll run the year 2008 with different tax rates and see what happens. So you can't, it's observational data because you're just looking at what's happened and you can't actually control it to find out anything. So often, that's what's used in those sorts of areas, but it's not particularly good data. Okay, anything else? H. You need to avoid claiming causation when there is association. That's something I talked a little bit about last Friday, and it's especially true to do with correlation and regression. Okay, now in regression, we found, say for Helen's choconutties, she graphed that line and it showed that as the temperature went down, the numbers of choconutties increased, the sales increased. Now, you might want to say, well, because it's cold weather, that's causing people to buy more choconutties. Okay. Whenever you do that, you have to think to yourself, is that the only possible explanation? And in fact, unless you run a controlled experiment, you really can't say things are caused. Another thing that might have happened might be that she works, or her little stand is beside somewhere that people go to in cold weather. Maybe it's beside a bus shelter, and in the warm weather they stand further away, in the cold weather they stand close and they go and buy her choconutties. Or it could be that there's other things you can think of. I can't at the top of my head right now, but often when you've got two things that are associated, like A and B, it might be that A is causing B, but it might be that B is causing A. For example, there is people who smoke and drink heavily, there is a correlation between heavy drinking behaviour and heavy smoking behaviour. Okay, does the heavy smoking cause the heavy drinking? Does the heavy drinking cause the heavy smoking? Or is there something else going on that a certain kind of personality, an addictive personality, actually drinks and smokes heavily? So just because you get a correlation between the amount people drink and the amount they smoke, that you can't actually say which is causing the other without doing a controlled experiment. I think it's probably one of the more clear examples. Is that clear enough? Got it? Cool. Anything else? Got 4 more minutes for your most important ones. Pardon?
Last one.
Oh, okay, sorry. Funny accent. Okay, most inferences assumes a random sample, but people do inference on random samples. Okay. Many statisticians are very protectionist. They say you have to have normal distribution, you have to have a random sample, it's got to be perfect or you can't do it. And the person who taught this before was much more like that. There's a whole lot of assumptions in these tests that I haven't even told you, because all it does is makes you scared to do them, because you might be violating some of the assumptions. The fact is that most data we get is not random. But all of the stuff, all of the p-values and so on, actually assume all of your sample is random, beautifully random, sort of like everything has an equally possible chance of being chosen. So you don't use stratified or clustering or any of those kinds of sampling, you use random sampling. However, random sampling is really, really expensive, just about impossible a lot of the time, unless you're talking about manufacturing processes and things like that. But to do with people, random sampling is very, very difficult. So mostly we don't actually have random samples. So what people do is they do the analysis anyway, and there's two sides to that. One is the analysis is better than nothing, but the other thing is that you have to be aware that it might not be quite as valid as it would be if the sample was properly random. And when you are looking at what other people have done, you need to look and think, okay, they took a sample this way, and one of the most popular ones to do is like a telephone poll. And I don't mean a telegraph pole, I mean a poll over the telephone. So a radio station says, okay, I want to ask about how many people think that the drinking age should be lowered even more. Okay, so then they get opinions from the people who ring up. And there's two things that could affect that. One is it could be the audience age of that particular radio station, and it's also the people who actually want to say something. You're going to get a different sample than if you randomly sampled all of the population of New Zealand. You would get quite a different answer. So you have to think about what is it about the way the question is asked or who they're asking that can make this different from a random sample, and that's called bias. So what I'm saying here is that though the inference assumes a random sample, we still go ahead, but be aware that there may be some problems. Okay, I'll just quickly run through all of the others. Okay, statistics is useful and give a company competitive advantage. This has been shown to be true. If you're going to help your companies in the future, stats will help you. Subjective opinion. Statisticians' opinions do not disappear when they turn on the computer. Anyone who says that statistics is the hard facts and unbiased clearly has no idea that statisticians are human beings. We always put our own values into there whether we like it or not. The point is to actually think about what is it that we're doing that could be affecting the result that we're getting. No doubt about that one. Yeah. Okay. This is an interesting one here. Number crunching will always do better than human judgment. People do not believe this, but it has been shown to be true that if you can get some numerical analysis into your business, you will have an advantage over those companies that don't. Effect size, significance and usefulness, we talked about the other day. You can have an effect, something that is significant, which means it exists in the population, but it can still be not particularly useful and quite small. And that's sort of tied in with that one. This is probably sort of the fundamental rule of statistics. I don't think you can go there. You can read up about that on Wikipedia. Yep, graphs. Yep, we've covered it all. Okay, so that's it for stats. I hope you've realised that stats is exciting and cool. And if you want to carry on with Stage 2 statistics, you can either do MSci 210, which is a paper taught in the Department of Management, or you can try to get into a Stage 2 stats paper. Now, what I would suggest is, because they don't actually want this as a prerequisite, is just hassle them, because they know perfectly well that you do just as much stats in this as they do in their 100-level paper. And if you need some help, just let me know. So, yeah, if you want to carry on with stats, don't let them stop you.